And now we take a look at interest, but just simple interest. So if you have a vague memory of compound interest with all that craziness, not going to do that till much later. So simple interest, which really only exists in math land, you have the principal, the annual interest rate, and the time of the loan in years. So the formula we use for this is the principal times the rate as a decimal times the time in years. So make sure you pay attention to the units on this. So this formula only calculates the interest. It doesn't include the principal that you have to pay back as well. So some problems we'll talk about it one way, where it's the full thing you have to pay back would be the principal and the interest. And sometimes the problems will be like this one. It says, if the total interest after 1 year was this, that is just the interest. And you can see, because up here, the total he borrowed is 22,000. So yeah, 22,000 is not included in 910. Other problems, it may not be so obvious, especially if it's realistic. The amount of interest you pay on a mortgage over the life of the mortgage is somewhere between like 1.5 and 2 times the value that you originally pulled. Yeah. All right. So I'm talking in math land because banks don't loan money for simple interest. They like to do compound interest and ridiculous high interest rates, and you miss one payment and oh no, everything goes through the roof, and yeah. All right, but Wes in Mathland borrowed a total of 22,000 from 2 different banks in Mathland. One bank charged the equivalent of 4% simple interest, and the other charged 5.5% simple interest. When I copied this, they didn't originally have simple twice, but I put it in there because to me that was a editor typo. If the total interest after 1 year was $910, determine the amount borrowed from each bank. So I ripped this from the book. So if the numbers don't work, we're going to blame the book, but they should work. That's why I ripped them from the book. All right, so the first thing I do on these, especially when they have a formula we can make use of, which we can, we have interest equals the principal times the rate times the time. So since there are 2 different bank accounts, I am going to make 2 rows, and then I'll make a column for each of the values. All right. This can look a little weird, so bear with me. So there's also technically a invisible third row that I don't actually call a separate row, but that is the total row. Because some of the things they tell us have totals. Totals are also where we're going to find our equations. Now, if you look at an ALEKS explanation, they are going to desperately try to write this without writing a second variable. When we get towards the end of the course, you totally do this with a second variable, way more straightforward. So I'm just going to approach it from that perspective, but I'll explain how you rearrange things so it would look like what ALEKS is expecting. So our totals, Wes borrowed a total of 22,000. So these 2 rows here are bank 1 and bank 2. So he didn't borrow 22,000 from bank 1 or bank 2. It's the amount those 2 together total to 22,000. And that's my triple zeros that get chained together. One bank charged 4% simple interest. Now remember earlier I said we needed it as a decimal, so I'm just going to do that now. 0.04. And the other one, 5.5, we moved the decimal twice, so it'll be 0.055 now. And we have the total interest after 1 year is $910. Ooh, another total. 910. And snuck it in there all ninja, 1 year. Time in years. 1 and 1. Yay for easy calculations. But we have 4 unknowns, blank still, but we have totals down there. All right, so let's talk about this principal column. If I call the amount that I'm going to borrow from bank 1 X, you can call it A if you want, letter doesn't matter. X plus whatever I borrow from bank 2 has to total up to 22,000. So just for a second, I'm going to call it Y. Watch. Ooh, oh no, Alex will freak. So when we have a total, it means all the stuff above it adds up to equal that total. So this is giving us a mini equation. I call it a mini equation because we are going to immediately solve for Y and put that in up there. So X plus this Y that we're not supposed to use equals 22,000. Well, I want to know what Y equals. So I'm going to keep Y and move the X. So if I move the X over, now this Y I'm not supposed to use is the same as 22,000 minus X. So now I'm going to take that and just shove it in there in place of the Y. And in fact, I'm going to do it quite literally. So if you look at an Alex explanation, that is what they will put in that column, and they do it like snap. There it is, obvious. Not obvious. All right. Now here's the next part that can feel a little weird. A couple of ways to write it. So I know the principal, or I have a symbol for it. I know the rate, I know the time. And my formula tells me if I multiply those, I get the interest rate, or the interest amount, sorry, the amount of interest that accrued on that account in 1 year. So I multiply those, and I'm going to write it over here. So 1 times 0.04 is 0.04. I don't know what X is, so I'll just write 0.04X. This one's a little uglier, but the 0.055 times that guy. This is why having Y would look easier. Not to mention that's just, yeah. So those two expressions are the interest for the first bank account, the interest for the second bank account. Whatever those two numbers come out to be, they must total to 910. So there is the actual equation we're going to solve. Later on, we'll just leave the X plus Y equals 22,000, and then we'll have this in terms of X and Y, and we'll have two equations with two unknowns called a system of equations, and we can solve. But that, like, it's literally the end of the course. We could do it now, but we talk about another weird thing within matrices. So here's a crazy equation with ugly decimals. Now, the only nice thing about the decimals is, because we're usually dealing with numbers that are insanely huge. So we have come up with the equation. To me, that's half the battle. As long as the equation you get is right, it's like, whew, I got through the annoying translation part. Now I just got to follow the math. If you don't like decimals, you can clear decimals. In this case, this is, we would call it 400ths. So we would multiply everything in this equation by 100, and it would clear the decimals. But because of the parentheses here, people tend to make mistakes when they try that. And I find for this problem, because the 22,000 is so big, clearing the decimal, we could, but it's actually not that bad. That being said, calculator. I don't want to do 22,000 times 0.055 by hand. My brain is not awake enough for that. Plus I will crunch that in a second. Because I don't have a fancy calculator easy to get to. But I have one on my phone. This isn't a test, so I can use it. 0.055 times 2200. And where is it? Yeah. And then we hit the equals, and we actually get a pretty number. 1,210. Yeah. So there's that. All right. I've got some x terms I'm going to combine. This one and this one. And we're going to end up with negative 0.015x. Now, don't freak out that we got a negative. Trust the equation to take care of it. Don't freak out until you get to the end. If you got a negative at the end, then it's okay to freak out because x should not be negative. But on the crunching in between, it's okay. Insert space. And go back to draw. Sorry, new program, getting used to it. All right. Now these were on the same side of the equal sign, so that's why I'm not adding 0.055x and adding, because that would be adding it twice on one side of the equation. Remember, equations are like a two-pan balance. So if I add something to the same side twice, it's no longer balanced. All right, but now I want to move this 1210 to the other side. Now I can do my same thing to both sides, which in this case is subtracting that over. So the negative 0.015, the x stays. And now you see 900 something minus 1200 something. Yep, this is going to be negative. In fact, it's a negative 300. Yay for pretty numbers. And then last step, we have the negative 0.015 smushed onto x with multiplication. So to get rid of multiplication, we divide. 2 times x, I divide by 2. This is the same idea, it's just an uglier looking number, but whatever it is what we divide by. I say this because sometimes I get students want to write plus 0.015 and plus 0.015, and well, then they end up with a negative number. They get confused, rage quit, I hate math, which I totally get. There are definitely days where that feels like the way to go. Alrighty. 300. Now my calculator is a little backwards. To get negative 300, I had to type the number and then the plus minus. So if you're using an older calculator, that may be the case. Most of the new graphing calculators, you won't have to. So the negative 300, close the parentheses, divided by, oh, well, let me do the negative first. Okay, 0.015. And then we close it. And it says 20,000. Woo! Nice, pretty number. So that's another like gut check for Mathland problems. For something with numbers this big, like if it was 20,114, I'd be like, I don't know. But 20,000? Okay. So now we have to rewind, which I will do by zooming out. There. So we're saying he got 20,000 from the bank that had the 4% simple interest. Woohoo, go West. So knowing what we know about the other account, they have to total to 22,000. So this tells us the other account is only going to be 2,000. So before we even check, let's first, 20,000 is at 4%. And we can sneak the $ in there. Likewise, 2,000 is going to be at the 5.5%. So to check this, what I'm going to do is calculate the interest and add them up. So I got 20,000 times 0.04 times 1, but that won't do anything, so I'm not going to write it, plus 2,000 times 0.055. And there it is, 910. Let me, not what I wanted. All right. So this works out. There is our answer. On ALEKS, they will probably give you 2 different blanks to put the answer. Pay attention to which account is in which blank. Sometimes it accidentally gets switched, just computer glitches, so pay attention to that. Alrighty, stop this one.